Hey there, David Veidt. We're in my lab, and behind me here we're making some carbon nanotubes, so let's check it out. So here we have...
So what we have here is the vacuum apparatus. I constructed this out of quartz. It's clear fused quartz annealed to the crystalline state. And then we have some titanium pass-throughs and some titanium coils inside. The electrodes are made out of tungsten and carbon, which has been machined to some precise geometries as required. And we have a gas inlet stage over here, and then we also have a mechanism for focusing the plasma. I can pull the control rod back, as I'm doing here, through a magnetic coupling and actually change the plasma focus and some of the dynamics. And we also get a glow discharge here in the tube that I can use in high voltage operation to change the resistance. So this is a pretty common plasma phenomenon going on right here that we see. You can actually calculate voltage from the number of steps you get there. So we're going to bring it back into the prime focus here, and that's actually the focus we need for growth. And then you can see off to the side we actually have the ampule where we keep the precursor, and that's what's actually flowing through the cell. And we got a pretty good view inside, a pretty close-up shot of the electrodes and the glow discharge coming through the injection port electrode. And we're going to start injecting some of the hydrocarbon precursor gas, and we'll get some changes in the plasma dynamics as we do that. We're going to change the pressure and kind of keep an eye on the vacuum gauge as we're doing that. We've got a little bit more of the glow discharge there. Yeah, since this is made out of quartz, it passes all the radiation lines right down through the ultraviolet, so we do and can get ozone generation and ionizing radiation. So yeah, a little bit different than regular glass. And keeping an eye on the vacuum gauge. So we got the pretty nice glow discharge going here. We're going to keep an eye on the vacuum pressure, and then we're going to start injecting some of the hydrocarbon precursor gas, and we'll notice a large macroscopic change in the plasma dynamics. And we're just about to inject. There it goes. So we're injecting the hydrocarbon, and it's reacting through the plasma. We're actually using a liquid precursor, so we're taking the precursor out of this quartz ampule, and it's getting boiled off in the low vapor pressure and getting passed through the plasma, reacted. The hydrogen's getting drawn off through the vacuum pump, and the carbon, when everything is dialed in right, will grow right on the face of this electrode, and it grows quite rapidly when all of the parameters are tuned and the pressure and flow rates are dialed in. This grows very rapidly. Right here we're in a growth slash destruct kind of modus, where the nanotubes are cracking off. So there's a little bit of instabilities in the vacuum and the discharge here, which are causing those propagating nanotubes to oscillate, and that oscillation causes them to crack off. So that was one of the fine-tuning mechanisms that had to occur in order to achieve efficient growth and also large length on these nanotubes, which is the holy grail. Yeah, and then in another variation of this experiment, I'm taking small crystals of diamond and embedding them in the surface of the electrode, and using a very similar hydrocarbon precursor, I am able to enlarge those diamond crystals in an epitaxial process. So I'm not growing diamonds from scratch like nature, but with a tiny seed crystal I can grow that to a much larger, macroscopic crystal, and that process can be repeated ad infinitum. I can break off a little piece and grow it to a much bigger one and keep on going. And also I can control the dopants that go into that diamond just by injecting various dopants along with the precursor. So very exciting science. Ionics at cox.net if you'd like to learn more. And now we're going to go back under the scope. We've got a nano rod growing.
What's nature doing here? Carbon nanotube kind of looks like a peanut.